Can you hear me?
Hello? Is that on?
It's on.
Oh, we have to switch between the two?
No.
I'll just wave around.
Okay. Well, hello. We are Team STRATODEAN. We're very excited to be here today to talk to you. My name's Mark and this is Cassie. We're both from the Forest of Dean in Gloucestershire. As a quick intro to our backgrounds, I have a degree in mobile communications and internet technology from Swansea University, and Cassie's got a BSc in human sciences from University College London.
Okay, our science and engineering backgrounds have come in handy, but we're most definitely amateurs. This is our first project, and the whole experience has been a steep learning curve. Bear with us, because we've only had a couple of days to prepare for this presentation, but when Dave invited us to speak, we didn't want to pass up such an amazing opportunity to meet up with experts in a similar field, and one that we're keen to learn about in a bit more detail. Our project, I guess, is just an example of what you can do when you merge amateur radio tracking with a giant balloon and the power of what you can learn via the internet.
Okay, also known as a HAB, a high-altitude balloon is when a balloon and payload tied together with a parachute reach an altitude above 12,000 metres, known as the Stratosphere. There's many types of HABs released every day by weather organisations around the world, which are used in meteorological predictions, where our balloon carried cameras and tracking equipment.
Admittedly, it's not the most obvious thing to just decide to do on day, but that's pretty much how it came about. As I imagine is all too common these days, it was a simple matter of seeing something on YouTube and thinking, you know, we could have a bash at that. We pretty much learned everything from that point onwards. From the outset, our primary aim was to take some photographs of the curvature of the Earth, and also to just set ourselves a bit of a personal challenge.
Yeah. Okay, so just a bit where our name came from. We're from the Forest of Dean, so.
Ta-da! One of the biggest credits to the HAB community is the UK HAS online resource, which is there. This has to be the first port of call for any enthusiast or newcomer, and we can't praise them highly enough for all their help and support along the way. The UK HAS site is made up of lots of how-to articles, advice and example coding. They also have a chat facility on there where anyone interested can pop by to discuss their project or get a bit of guidance. When a launch does roll around, the UK HAS has a healthy tracking community, which some of you are part of, and distributed tracking infrastructure with members dotted across the UK and Europe, all tuning in and tracking the progress of the balloon. Obviously, the more the merrier, so that's great. Now with the payload construction, it looks a little bit different to some of the payloads we've seen here today. But in true Blue Peter style, this was a DIY sort of task. We got a special sheet of... go back. We got a special sheet of closed cell polystyrene, which is nice and waterproof, and along with some special glue. And basically, boom, job's a good one. So there's pretty much anything goes within reason.
Today.
There it is, that's the one. And pretty much it's all about keeping the weight down, because a lighter payload is cheaper just in terms of helium.
Okay.
Be gentle. The next bit is really tracking the payload.
Okay, having a real-time tracker was a big requirement because it would allow us to track the balloon's journey live. And with the help of the prediction software provided by UK HAS and the Cambridge group, it meant we were able to predict where the balloon was going and track and drive to the predicted landing site. We decided in the early weeks of the project to use a radio-based tracker, the kind that most radio enthusiasts, high-altitude balloon enthusiasts use to track our balloon. There were a few reasons for this. It was a proven technology. The radio infrastructure already exists, and I really like the idea of setting myself a challenge of building one of these. Okay, so how does it work? So we're going to talk about the hardware first. To build a GPS radio tracker, you need three things. You need a GPS module, a radio, and a microcontroller to control them both. In a high level, The way our tracker works is you have the microcontroller, which is in this case an Atmega 328 chip found on an Arduino Uno board. Ask the GPS for position information, format it, and then pass it back to the microcontroller for then onward radio transmission. Okay, so I'm going to go into that in a little bit more detail. Okay.
There it is.
Got it here as well. So this is what I built. It's a bit. There you go. Here at the bottom is the Arduino Uno prototyping board, and at the top is the tracker with all the components. I chose the Uno because it's economical, readily available, and the easiest way to get into hardware development. If you aren't familiar with these, people use these all the time to control any electronics, like hobbyist kind of things. To do fun projects like control your window blinds or make LED clocks or something like that. They let you interface hardware components and control them all with software in a way that's easy to use for the beginner, but with plenty of processing power for more advanced applications. Okay. Let's talk about the GPS module. When picking a GPS, we have to be very selective about which module we chose, because not all of them work in the stratosphere. The last thing we want is for it to cut out a certain height, and then we not know where it is until it came back down. So we went with a HAB staple, which was the U-Blox Max 6 chip, because of its proven reliability and its flight mode functionality, which meant you obviously can use it up in the stratosphere. We purchased it along with the Sarantal passive antenna, which provides excellent signal along with low power consumption. The radio module, in the UK, the HAB flights typically use the unlicensed 433 to 434 megahertz frequency. To make this easier for the hobbyist, a company called Radiometrics make two frequencies available through their prefabricated RF transmitter module. It comes in two set frequencies, the 434.075 and this the 434.650, and we had the 650 version. Okay. For the antenna, I created a quarter wave antenna out of some RG58 coax cable. I spent a few tedious evenings unbraiding this cable and to use as a ground plane for the main element, which I've got here. So I've just literally put the cable out and split the shield in there. I'll have a picture of that. Also on the tracker, we've added an SD card. So the idea of adding an SD card to the tracker was to initially help with debugging, because we were getting some weird outputs and we weren't sure where things were going wrong, and so I thought, well, if I saved it all and I can go and look at it again later. Then after it was all okay, we used the SD card as kind of a black box, so we could record our position and status information, and then do cool things like overlay data onto our videos, which I'll show you in a little bit. On the second launch, we added two temperature sensors, one external on a probe and one internal to tell us the difference between obviously inside the payload and outside. These were made by a company called Dallas, and they were one-wire sensors, which means we could just use one pin on the Arduino and then remotely address them. Finally, we used... What's that one? Oh yeah. For power, we used 6 AA Energizer lithium batteries because of their proven reliability in colder temperatures. So after breadboarding all the components, I soldered them together onto some strip board like this. I made my own what's called an Arduino shield, which meant I could just plug it in And then when I wanted to control my own blinds at home, I could just unplug it, and then not that I've done that yet. Okay, just going to take a quick look at the software. Just a quick look. To program the Arduino, you use the free IDE, which you can download from the website. All Arduino software needs two functions as a minimum, which is a setup, which initializes all your variables and sets everything up, and then a loop code, which will just run continuously forever then until you switch it off. On here you can see that, I'll just go through it quickly. At the top we're just initializing our LEDs, we're setting our serial port to talk to the GPS we started. Oh, I can use the pen. Here we initialize our GPS, so we do a subroutine to that, which I'll show you in a sec. And then we log then to our SD card to say whether we can write to it if there's one plugged in or anything. Here's our GPS code. Basically, we're talking to the U-blocks in its proprietary language here, just saying we don't want all of these automatic messages, we'll just ask you for some location information. And this is the very important bit, the setting the navigation mode to flight mode, because otherwise it turns off at a certain height and you don't know where it is. And quite simply, here's our loop. We're just getting some battery voltage, getting our temperature from our sensors, calling the get info, which is a program that just says, give me the information, and then we're sending that then to our radio. Okay, about the radio. This is a schematic of that NTX2 module from Radiometrics. Our payload transmits at 434.650, and we transmit using RTTY at 50 baud with a 350 Hertz shift on the upper sideband. We do this in our software routine by setting the Arduino pin, which is that one there, high or low, and using our voltage divider there, we create the shift using the resistors there. Our routine in the software just breaks down the location data string into different ASCII characters and then sets the pin high or low as the binary requires, and then sends it down the line. Okay, we'll come on to receiving the signal shortly.
Okay, then as with all things technical, you can never be sure that things are going to go quite according to plan. So we recognise this and mitigated against it by buying a GSM GPS tracker. That one sends SMS text messages with location data to our mobile phone. We bought this for a decent price from eBay and included it in the payload just for that added peace of mind, as of the video camera we put in there was a bit of an investment for us. Ironically, our radio tracker worked perfectly, and for some reason that one packed up and just didn't want to play. But just one of those things, typical. But okay, so the next bit, so we had the tracker, we had the payload, and now, or someone kindly named it our spaceship. Now all we needed was a method to capture the evidence. If it's going all the way into the stratosphere, we want to know about it and we want to get some proof. This came in the form of two cameras. We also try and exploit existing technology. We have our standard point-and-shoot model from Argos and our GoPro. So the point-and-shoot's downward facing, GoPro is going out to the side.
It was side-facing on our second launch.
That's true, actually, yeah. They were both side-facing on our second launch. Basically, the GoPro is a really good video camera, nice and robust in case of a splash landing or anything like that. It also features the fisheye lens, which gave us a little bit of a wider angle to be able to be captured. We used the Canon Hack development kit to script the autonomous operation of the still camera, so then it would continually take photos every 10 seconds. Near space isn't the most cosy of places, so one of the more unusual parts of our project came where we had to test it. We used it in the most hostile environment we had available, which was sandwiched between the peas and the chalk ices in our freezer.
Okay, planning our hab launch was a balancing act. Once we had the payload sorted and were confident about its weight, the next task was procuring a suitable balloon and parachute. So weighing in at a kilogram, our payload was fairly sizable. the main trade-off when deciding on the balloon is the cost versus height and distance. We had a target of reaching 100,000 feet, so we needed to purchase a balloon that would comfortably meet this. As a general rule, the larger the balloon is, the more helium you need, and therefore the more expensive it's going to be. Once you've chosen the balloon, the next variable is how much you're going to fill it.
Okay, yeah, so an overfilled balloon will ascend quicker but reach a lower altitude, whereas the underfilled balloon potentially hasn't got enough oomph to get into the bursting altitude and can just float around aimlessly for a couple of days, which we didn't want. The Goldilocks balloon, which is just right for us, reaches the target altitude and bursts very shortly afterwards, meaning it will descend to Earth a reasonable distance away from us to go and retrieve it. The slide here is of the Ascent Calculator provided by the Cambridge University Space Flight Team, so that's a really good resource for us to use. We selected a 1,000-gram balloon with an ascent rate of 5 meters per second. Because we were aiming for 105,000 feet, which is approximately 32,000 meters.
I think, yeah. Our payload was slightly higher than that. It did go, that calculated a little bit wrong, never mind.
Once you've sent it up, you've got to make sure it comes safely back down. Again, this evolved around the required descent rate, and we selected it to be 6 meters per second. Once our parachute arrived, it was subject to some very rigorous testing, which is basically Mark running around the garden. We chose the Rocketman 4-foot parachute. There it is.
And that's the remnants of our balloon from our second launch.
Okay, so in addition to the calculator, the Cambridge University team has also developed an online hab flight predictor. We have some predictions here. That's one launch that we decided not to do because it was a little bit far for us. And whereas the next one, that's one we went for, a nice little landing in the Brecon Beacons with that one.
That was our first launch at Milton Keynes.
Oh, was it?
Yeah.
Oh. That's the one that went the other way. Milton Keynes. Sorry. Apologies.
Our second launch landed in Brecon
Beacons. Yeah. We actually set up our own version of this flight predictor using a Raspberry Pi to give us our own potential flight paths at hourly intervals so we could keep an eye on it. Prior to launch, you need to seek approval, and this is done via the CAA, the Civil Aviation Authority. They will then issue a NOTAM to other notification to airmen on the day of your launch to warn others to keep out your airspace. The CAA approval is free, however, they do ask for 28 days' notice if possible. As you can see, you can sometimes request a bit of a launch window or specific days, and you've got to be prepared. People will ring you up for updates and to see if you're going, so they can avoid that airspace.
Some were happier than others.
Some are friendly, some aren't quite so happy.
Okay.
Right, so the preparation's done. Now it's time for launch. We're going to run through our virtual launch using footage beginning firstly with our first launch, STRATODEAN 1.
Okay, so we've got a short video.
We did have an embedded video, but
things didn't work out.
But we've got a backup plan. Oh, here it is. I find this a bit embarrassing, so I might kind of hide.
We can't hear it. Is that okay?
Going to turn it up. We're going to be really happy to be on the internet. Base layer and shim and payload. Video camera on, capture on. It's all about roping in the family.
camera. He's going to swing towards you, Joe. Joe's going to swing towards you.
Is he going to swing towards me, is it?
Yeah, get the balloons off you.
Oh, go for it. She's so fast. Okay, everyone wave because you'll be on camera.
Be on camera.
Okay. Ready? 1, 2, 3.
Okay, so we're in the air. Let's go back to this.
Okay, so now you're in the air, now you've got to track the darn thing.
Okay, I'll leave that. The balloon is airborne, so we better track it and see where it's going. I used a USB TV dongle and software-defined radio. This will capture all the frequencies and use software to process them, as opposed to a more expensive proper hardware radio. I attached to it a hab amp front-end amplifier to filter out the other signals and focus it on the 70cm area. And here it is.
There we are. Waste not, want not. Proper with Aquafresh box.
Yeah.
The best we can find.
In conjunction with the STR software, we've used this tracker on numerous occasions, both on our launches, for other people's launches, receiving images from the SSDB payloads. So it didn't cost very much, even maybe £50, and I mean we can receive.
It's good because it's accessible for all, because you can just do it, be a beginner, you don't have to shell out too much, and you can get bitten by the bug, so to speak.
Yeah, and then buy a proper one later. Okay, we used DLFR Digi, which is the software used, the sound card decoding software used by the havers. It takes the audio from the radio and decodes the balloon's RTTY signal, and then sends the telemetry it's found over the internet to a central server, which then collates it all from the other radio amateurs and plots it on a map, so we can know where it's going. Okay, so we're going to go back to the flight now. Now we're tracking it.
Yeah, so this time around we're going to be looking at our STRATODEAN 2 footage with the flight data overlaid over the top, and we'll follow the balloon until it lands, getting a bit of insight how stressful it can be when you don't have any signal.
A little bit longer, but it should be fine.
So that's the way.
On this video, we're going to relate the telemetry data, so we should be able to know where high it's going.
Just gives you an idea really into some of the pictures. I think someone said you're interested in kind of exactly pictures you can do.
Okay, after a bit of a stressful time at launch site, we've launched our STRATODEAN 2 balloon. There's some tracker issues, so we kind of delayed by 40 minutes before it took off. We're on our way now to Brecon and further.
Colleagues in Chase Car Mini, woo! Look at him, bopping and a weaving. How's it going now, Mark?
Lost our signal again. Our 3G signal.
Why do you think that's happening? Because
Because we're in Wales.
whoa now. than an entire nation.
It's just hilly, I think it's
It's because it's a bit hilly. We're in the valleys, and it's just having a slight impact on our tracking abilities here. But everyone else is tracking well for us, so big thank you to those people. And this is yeah, it gives a good idea of we're in a bit of a dippy. Oh, nice pub, right, dippy.
Should have stopped.
I know.
It's quite interesting to note that the temperature actually increases now. I think it gets to minus 25 and then it goes back up.
Is that the English channel?
Yeah. I think we're just coming over the that bit there, I think is the English channel. So
That's another good shot of our valley locations, everything. Maybe it's to show you this one. That's where we are. And that's where we came from. There wasn't a lot to do. We didn't have much signal.
it's gone back up to minus 590. That's the English channel.
This appears to be one of the dangers of launching on a weekend. Ballooning enemy.
Number one.
The caravan. Bum bum bum.
Any caravan drivers in the room? Not anymore.
I think we should be bursting soon. You can actually see the remnants of the balloon come into shot in a minute as well, hopefully.
Here we go.
Why is she out to complicate?
It's because of the... oh, there's the balloon. It's because of the fisheye lens on the camera.
You can straighten it out with software, I think, can't you? We're free falling.
Half speed. When you're listening to it, when you're tracking it from home, you can sometimes tell when it's burst because like the frequency goes around. You see
Because there's no atmosphere at this point, obviously the parachute hasn't deployed yet, so it's just... With no current 3G signal, we are currently reverting to the old-fashioned method of the map. To our younger viewers may not recognise these, they're books just with pictures of the earth, really, and the roads. That person on the internet is probably suffering now. Here we go. This is our Brecon Beacons, nice and picturesque. We've barely got mobile phone signal, we've certainly not got any 3G or we can't get on the internet in any form. So, I think I'm going to lose the mobile phone signal and we're heading towards Landauer. I'm pretty sure I didn't say that right. I don't know. Here Here we go. It's conveniently next to a road, which was very thoughtful. Well, guys. Very glamorous. Unfortunately, someone beat us to it. And we were about 10 minutes later, weren't we?
How do you think the launch went, Cass?
I think that it was, in some ways it was quite stressful because we didn't have as much time to prepare because we knew we wanted to do it as soon as the opportunity arose. So we did. So hence, because the weather was nice, there's a little bit of an issue with the tracker, just a little bit, one of those things. So that was a bit of a worry. And then it was going in a different direction into the back of beacon, so there was not very much mobile phone signal. So that was a little bit stressful regarding trying to keep getting updates on where it was heading. But in terms of where it actually landed, it was quite nice. It was nice and open, but extra road, and it was quite pleasant with some sheep. And for that bit it was nice, and it's not so far to drive home now again either. There's definitely some food on the way.
Sitting down on the job.
This is pictures from our still camera at the side, so you don't get
The curvature, like, yeah, the concave.
Okay. Just got a couple of little things to say. Okay, so what's next? Early ideas for STRATODEAN 3 include a camera facing upwards towards the balloon so we can capture it bursting. This time around I've also designed and built and had fun with circuit boards and stuff, and built a bespoke circuit board for our tracker, so we won't have to use like these bits. We can just combine it into one. Basically I've taken the chip from the Arduino and going to surface mount it directly on there, and here it is, just nice and small. So that came from Hong Kong, I think, last week. So that was good. And that's it, really.
Yeah, I mean, the rest of the hub community, there's lots of exciting projects going on there at the moment as well. These include channel crossings, and also branching out into other prototyping boards such as the Raspberry Pi that gives more power and also allows functions such as live image streams. So it's a lot going on there at the moment, and obviously you guys get involved with the tracking. It's a nice community.
Thank you.
Yes.
Mark and Carrie, thank you very much indeed. That's really inspiring to see so much activity going on, and it's not quite into space, but it's jolly close. It's much closer than any of the rest of us can manage. So, any questions from the room? We're going to throw this microphone around. We're a bit microphone starved.
Do you have any consideration for a command receiver so that you can send a signal saying operate the release for the balloon? Should CAA want you to implement that? Obviously, from the sounds of it, they haven't asked you to put that on.
No, it's not a requirement at the moment. I know that some people have looked at sending signals upwards. I'm quite not that advanced in my radio kind of working just yet. So I think that'll be something to maybe research and look into. I know some people have sent signals up, and obviously you can do a lot more if you can tell the balloon or the payload to do something at a certain time on the push of a button rather than autonomously. CAA haven't really said anything about that just yet. So.
Firstly, congratulations. That was a really nice movie, and I think it showed the excitement of actually tracking. That's really well worth watching. Can I ask you if you managed to monitor the temperatures internally as well as externally that you put on the frames there, and how did they differ?
We did manage to record it. I just didn't put it on the video. To be honest, they stay quite static. They didn't fluctuate at all, really. I think the box itself was quite insulated because the camera was like wedged in the hole, so there's not much air that got in there. That also attributed to the frequency, the non-drifting of the frequency, because when you use these NTX modules, if you don't insulate them very well, the frequency can kind of drift. So I think, without really planning it, we'd actually designed a quite well insulated box, so that the temperature.
Welcome to have a look if you're interested. But it's all done in layers, so everything's pretty snug in there, and I think it actually turns out to be very insulating. So that was something that was a happy
coincidence.
Okay, a couple on the internet. One is, what is the length of the tether between the payload, chute, and how is the length of the tether between the payload, the chute, and the balloon determined?
I can't remember the exact length, but I know it's 2 to 1, isn't it? Because when the balloon bursts, you see we had like remnants of the balloon. If that like flops over the parachute, we don't want to get in the way of the camera.
Or the parachute or the camera.
Yeah. So the one between the parachute and the balloon is always a lot shorter, maybe half the length of the other one.
Okay, and the other question is actually from myself. You talked about the two communities, the ballooning and the amateur radio community, coming together and working really well. Yeah. And I've tracked quite a few of these. One thing that concerns me slightly is that we need to coordinate the use of frequencies more carefully. Yeah. There are certain frequencies which are used on amateur radio repeater inputs. Yeah. And I think if the two communities want to coexist, we just need to do a little bit of work on making sure they're coordinated. There has been one or two discussions on the IRCs, and it gets rather hot-headed. But I think work needs to be done to make sure we do coordinate properly between ourselves so we can work together.
Yeah, definitely agree. Yeah.
I mean, I imagine this is kind of something that begins on that as well. You know, we kind of come and say hello to you guys, and you guys can come over to UK HAF and stamp your mark on there as well by all means, and we can organise it.
To try and help in the frequency coordination, and in fact hopefully permit some more powerful transmitters on different frequencies which would not be subject to so much of the interference that currently that we all struggle with from the SRDs, the short range devices, the garage door openers, and the external temperature sensor weather station stuff. So watch this space on that. Any other questions? One at the front.
Well, congratulations. It's great to see it, because our apprentices did something similar, but we lost one balloon. How many balloons have you lost?
We've had 100% success rate.
Really? And secondly, how many miles did you do chasing it?
Yeah, it's about 100 miles to Milton Keynes, but Brecon was about 50, 60, because it all depends on the wind, really, on the day.
We are quite picky. We avoided the one up to Hull.
It's too far.
Okay, well, I think if there's no more questions, we're running slightly over time, so we should say again thank you very much indeed for coming across to join us and to present. It's been really exciting and sort of invigorating, really. Please stay. I hope you can stay for the rest of the day or to the evening, and then our delegates can have a look at your equipment and pass judgment, because radiometers tend to be fairly judgmental, so please understand that. So thank you very much again. Thank you.